Yeah.
Contact forces.
Yeah, and non-contact, yeah.
Okay.
Yes.
An atom is the most outer thing in an atom is the electrons.
Yes.
Right? So everything is made up of atoms and
Yes.
molecules.
Yes.
So
Yes.
the electrons repel.
Yeah. The what repel?
The electrons repel
Yeah.
each other.
Yeah. Yeah.
Technically, there is nothing in contact.
Technically, at a microscopic level, there's nothing in contact. Yes. But at a day-to-day life, we can consider it in contact.
So what do we feel when we touch something?
The pressure of the electrons repelling your electrons.
The atoms repelling each other.
They're not touching.
No.
Blow my life is gonna die.
That's why I'm here.
Okay, now here comes the question.
Yes.
Where does the friction comes from?
The friction is to do with the structure. So, like, you're breaking the bonds that hold the
Surface?
the surface. The surface is like a mountain range,
Yeah.
and when the atoms pass over, these atoms they snap off. So the friction is the breaking of the bonds of the little mountains. Yes?
Yes.
Okay. Does make sense. All right, collisions now.
Collisions and then explosions. Is there explosions?
no explosion.
Exactly.
No. Maybe next year.
No, we used to do them when it explodes with the energy of this much. How far does the force fly out?
Kind of. We'll see. Do you have this? Collisions. Okay, so collisions in physics are problems like this. Yes. Now, it's a special type of problem in physics between two masses, and this is the key. There's no external force. So this ball does not have an engine in it. It was moving with a constant speed and it hits the other balls. Now, of course, something must have hit it to make it move, but the collision, there's no forces externally. There's only the moving ball that hits the other ball. There's no little engine in here that pushes it along. Okay? So this is what I mean when I say collision in physics. It's a different problem if it was an engine, which we're not going to look at. Okay? So we talked about the momentum before. Momentum is mass multiply velocity. And it turns out when there's a collision, the momentum is conserved, meaning that, like the energy, it doesn't change in total. So as a formula, we can say the momentum before equals the momentum afterwards, where m1 is mass 1 and m2 is mass 2, and u1 is velocity 1 at the beginning and u2 is velocity 2 at the beginning, etc. etc. I think it's pretty obvious. So you have like two balls, m1, m2, u1, u2, they come together and then they bounce away, and now it's m1, v1, m2, v2. Yeah? Okay, so the pretending, please, the pretending. Thank you. So really, this lesson is not so bad because it's just this one formula, and this formula is not so difficult. There's no squares in it. It's a linear formula. Whereas last time when we had the KE and the PE, there were squares in it, V squared, so it's a little harder. You all remember momentum?
Yep.
Yep, okay. Continue? You don't remember momentum. Not L, what letters for momentum?
Five.
Nope.
That
was impulse, correct?
Not
L. Not L, not angular momentum or turning force. No, sorry, L was, I used L for turning force. p,
Yeah.
small p for momentum. Small p. Okay, continue.
So P equal.
mv. Remember this? Okay, trust me, I did it with you. Now, broadly speaking, there are two types of collisions, elastic and inelastic. Elastic collision means that the kinetic energy does not change. So in other words, Ke at the start equals Ke at the end. This, of course, is not realistic because some energy will become heat and sound and so on. Inelastic, have a guess? What does that mean?
Opposite.
Yeah, so what would that mean?
Kinetic energy is converted into atoms of energy.
Yeah. So in other words, the kinetic energy at the start does not equal the kinetic energy at the end. Would the kinetic energy at the end be bigger or smaller than at the start? Smaller. Because?
They collide. They lose speed.
No, stop. Just think for a second. Why is the Ke smaller at the end than at the start?
It loses energy.
Into what?
Another form.
Such as?
Sound.
And heat. Yes.
Sorry, I have a question.
Yes.
The formula M.
M1U1 plus M2U2, yeah?
Yeah, why not cancel the M?
Because it's M1, M2, they could be different.
But in the other side is also M1 and
Yeah, but you can't cancel them.
Because there's an addition sign.
There's M2. Here, look. M1U1 plus M2U2 equals M1V1 plus M2V2. They do not cancel because when you divide by M1, divide. Yes? 2K? Yes? Alright. Those are important words because sometimes in the exam the question would be, is this elastic or inelastic collision? So you need to know which is which. So please, did you write them down?
But then almost everything is inelastic.
Yeah, I mean, if you have to take a guess, the answer is going to be inelastic. Now, not always though, not always.
Could you give us an example of an elastic?
Of which elastic? An elastic collision would be two like rubber balls, that when they bounce and they perfectly rebound. I know, so like in real life it doesn't really happen. It's always going to be inelastic because some kinetic energy has to be converted into heat or sound. Okay, continue.
Could you just say that again, what you said about the kinetic energy is going to equal?
Yeah, so when there's a collision, if it's elastic, then the kinetic energy before the collision equals the kinetic energy after the collision. If it's inelastic, then the kinetic energy before the collision will be greater than the kinetic energy after the collision because some of the kinetic energy became heat and sound. Continue. Right, here is a pretty simple example. I feel like you can do it already because you just have to use the formula. But just before you do it, let's look at what's happening. A 1 kg trolley and a 2 kg trolley, the 1 kg is stationary. So what does that mean?
The 2 kg is
Oh, sorry, the 2 kg is stationary. What does that mean? Yeah, U2 is 0. And the 1 kg is moving at a speed of 3. So U1 is 3. What's M1?
1 kg.
1. And M2?
2.
Yeah. I'll draw it for you.
No, I got
No?
confused with the stationary.
Yeah, because
2 kg,
what's happening is this one is at rest.
that's the 2.
Yeah, and this one is moving at 3 meters per second.
1 kg
A 1 kg trolley is rolling towards a stationary trolley. Okay. So, what's going to happen is these two are going to collide and they're going to form a new trolley. Well, I'll just do it here since I'm doing it now. Of mass 3 kg because they stick together. And its velocity, we don't know. We'll call it x. Let's calculate its speed. m1 u1 plus m2 u2 equals m1, well, m3 I suppose, this mass and this velocity. So the momentum here is what? What's the momentum here? What's the momentum here? 3. And the momentum here? 0. And that should equal the momentum here, which is, what's the momentum here? 3x. Remember, momentum is mass by velocity. So x is 1 then.
No, it's not. It's 3 plus 2.
So then 0.
Alright, so x is 1. Are we happy with that?
Good.
Yes, of course we are. Okay, so now, part B, what is the kinetic energy before and what is the kinetic energy afterwards? Okay, this part I definitely want you to do. I want the kinetic energy here before the collision and here after the collision. You now know the x. Alright, calculate that for me, please. Calculate. You got an answer? Come on, write it down.
K1 is 9.
Write it down.
No, it's not.
Write it down.
4.5.
Yes, it is.
Yes. So, kinetic energy 1 is a half m3 squared plus a half m0 squared. That's 4.5 joules. Kinetic energy 2 is a half 3
1
squared, which is 1.5 joules. So what has happened here?
Loss of energy.
Yeah, loss of 3 joules. Therefore, is it elastic or inelastic?
Inelastic.
Yeah. Last question is what type of collision is this? And if you go back, it is inelastic because some energy was converted. Okay, is that okay? Yeah.
So,
Yeah.
The bodies that combine together, but then they bounce off.
They move off together.
No, they don't bounce.
No bounce in here, yeah.
This is moving.
Yeah, so if a car hits like a car that's not moving,
Yeah.
it might like hit it and then like kind of stop.
Yeah,
Like,
it
that's what
depends. It
happens.
depends on the collision. So I often find that cars moving slowly when they collide, they'll just bounce off of each other. So they'll go like dunk like this. But if the collision is strong enough, the cars then become one car.
Okay, what about like let's say forward, you can hit the ball so like hit the ball and then stop and
Yeah.
then hit the other ball so that it continues.
Yes. Now it gets a little bit different there. I know what you're saying. You can hit the white ball so that
That's it, and like if
Yeah.
you hit it hard, it'll like smash the other ball,
Yeah.
but then stop, like not go with it.
yeah. This is maybe a question that comes up actually, because I think the next one or something in the homework is snooker balls.
If you add a spin to the white ball.
No, there's other things going on here possibly as well. But I think there might be one question on that
Might be
actually.
because of the spin, like it's, but then isn't it like supposed to continue moving?
No, we'll see. Look here. See, I'm already thinking ahead of you, okay? So let's have a look at this one here. A white snooker ball traveling at 2 meters per second strikes a stationary red ball. After the collision, the white ball is nearly at rest and 10% of the kinetic energy is lost. So what's happened here is we have a white ball with mass m and a red ball here of mass m. This one was moving at 2 meters per second and collides with this one. And some energy is lost, 10% is lost, kinetic energy is lost, because of the sound when you hear the collision. Estimate the speed of the red ball. Estimate, firstly.
Less than 2.
Yeah, but estimate first. So, in the question I said after the collision the red ball is nearly at rest. U1 equals 2. U2 equals 0. V1 is nearly 0. And my question is, what's V2? So, M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. So, V2 is roughly 2. Now, so that means if the white ball is moving at 2 meters per second, then after the collision the red ball is moving roughly at 2. But that's roughly, because this white ball won't be at rest after the collision. When you watch snooker, you know what happens. The white ball comes along, hits the red ball moves away, but this one kind of slowly it moves a little bit. It doesn't go like this and then perfectly stops and this one moves. If you watch carefully, it just rolls away slowly.
Or changes direction.
Yeah. Okay, but it doesn't perfectly stop. It's not like.
Well, what I'm saying is that, like, isn't it like supposed to, like, if they're combining to become one body, aren't they supposed to be moving together?
But there's nothing for the two balls to click together. There's no reason for them to stick together because they're smooth. So they'll bounce. Let's have a look at B part now. Find the exact speed. Okay, now we want to find the exact speed. So we cannot say this in the B part. Alright. So we have M1.
Isn't it just 10% of 2?
No. Well, it could be, but not necessarily.
It's the same mass for the red ball and the white ball?
It could be, but not necessarily, because there's a square in the velocity. So I won't commit to saying that it is. M1 U1 plus M2 U2 equals M1 V1, which is not 0, it's just nearly 0, plus M2 V2. So we get V1 plus V2 equals 2. Now our problem is more difficult. Why is it more difficult?
2 unknowns.
2 unknowns. But there is a piece of information I haven't used yet, and that is 10% of the kinetic energy is lost. Let's try to make that an equation. How can I make that as an equation of KE1 and KE2? Kinetic energy before, kinetic energy afterwards. 10% is lost.
Times 0.01.
Yeah, give me an equation.
After M2 squared KE1.
No, don't use the M's or the V's yet, just use KE.
KE times
Yeah,
0.01 equals KE2.
No.
KE1
Oh no,
times
fine,
10%.
let's stop guessing and just think. Write it down, and then when you're certain, you can tell me. What was your idea?
Minus equal.
Mine is equal. No, give me a second.
KE2 minus KE1.
Are you sure about that? Because KE1 is bigger.
Oh, so KE1 minus
KE1 minus KE2 equals
10.
Good. What do I write next?
0.01. I know
1 0. Yeah.
But then can't we do it like?
No, tell me what to write. It's not finished.
No, it's not. It's already finished.
Yeah.
It's KE1 squared.
K1 squared?
No. Not there.
Guys,
I
you're...
thought of it differently.
Right, go on, what did you think?
V squared.
No, stop it there. I don't want to hear V yet. Okay, look, this one loses 10%. So there's two ways to think about it. The way Swan was trying to think about it, the amount of kinetic energy lost is KE1 minus KE2, and that's 10% lost. So that's 10% of the original. Or, if you want to think of it another way, this loses 10%, so you're left with 90%. So this is 90% of this. So you could say 0.9 KE1 equals KE2. And in fact, if you take this and rewrite it, you'll make this anyways. Watch. If I take this to the left and this to the right, I get 0.9 KE1 equals KE2 anyway, so it's the same thing. I'm going to use this version because it's a little more convenient. Right, what is KE1? A half m2 squared. And what's the kinetic energy afterwards? A half m v1 squared plus a half m v2 squared. Remember, we don't know v1 and v2. What can I cancel here? M's and halves. So I get 3.6, don't I?
Yeah.
Equals v1 squared plus v2 squared. Now what have I done? I've made two equations with two unknowns. Yeah. So I take this one and put it into that one. We'll do this really quick. So what method can I use here? Substitute. I can say v1 equals 2 minus v2. So I get 3.6 equals v1, which is 2 minus v2 squared plus v2 squared. 3.6 equals 4 minus 4v2 plus v2 squared plus v2 squared. So I get 2v2 squared minus 4v2 plus 0.4 equals 0. What type of problem is this? It's a quadratic. What are the solutions, please? Do you have it? Do I have my calculator? Oh no, I don't. I closed it. Calculator, please.
They are
Yeah, go on.
minus 0.1 and
1.9 and 0.1.
That sounds like it.
minus
1.9 or 0.1. So then V1 would equal 0.1 or 1.9 by using this formula. So you have two answers. But which is the right one and which is the wrong one?
1%. That's right.
The first or the second? Which is the right one? The left?
Two.
Left or right? Which is it? Come on.
Left.
V1 is 1.9.
No. Yes. V1.
Is 1.9.
Oh, okay, right.
No, it's on the left.
You have two possible answers. Either V1 is 0.1 and V2 is 1.9, or V1 is 1.9 and V2 is 0.1.
Oh,
Yeah,
yeah.
0.1.
The one on
The
the left.
first one is right.
Yes.
First one is right.
Which accept and
Yeah.
reject. Why?
Because the V1 nearly zero.
Yeah.
Yes. Yeah.
But couldn't we just do it like 10% off two?
What is 10% off 2?
Oh, no.
So Faisal, I can now answer your question that does not work, 10% off.
No.
Because if you reduce 2 by 10%, that's 1.8.
Well, wasn't the kinetic energy before the collision greater?
V is after
Yeah,
the collision.
yeah. The kinetic energy before the collision was greater, correct. 10% of it was lost. Yeah. What's confusing you?
I forgot about the 10%.
Oh yeah. This one's a bit hard. It is a bit hard because you have two complicated equations to solve together.
I have a question.
Yes.
The second equation,
Yeah.
can't we square root everything?
No.
Because it's
No.
a 1.
Why not?
I'm asking you,
Because
because
it's
it's a
a
1?
Because it's a 1?
Yeah, the coefficient of the b's are
No.
is 1?
No, because there is a plus.
Yeah?
Huh? You know
Yeah.
Pythagoras is a squared plus b squared equals c squared.
Yeah.
We don't say Pythagoras is a plus b equals c. In other words, we cannot cancel the squares here by rooting these. You can check it out. Root 3 squared plus 4 squared is not 3 plus 4. Because root 3 squared plus 4 squared is 5, not 7.
No, if we root them separately.
How? You can't root them separately. You have to do it all on the left and all on the right. But deep down in your heart you knew that. That's okay. Alright. I think you might have to, if you didn't write that, okay, I'll leave it for a minute. Try to write it down. If you don't have it, you'll have to get it from the video. No, don't.
No, the thing is,
The pictures never work. You convince yourself that you will open your phone like... No, you won't.
You know his name, not his story. Don't judge him.
No, I will judge you. Be quiet out there, guys. Doing some physics in here. Have you got this? Once you've written it down, get out. I'll see you in cab in a minute. Trust me. No matter how bad you think it is for you, it is worse for me.
Will you get paid for it?
Not enough.
I'm telling you, tell them you will leave. You have so many classes, they can't let you go that easy. They'll increase your salary.
You'd be surprised. Everybody's disposable. Alright, can I close this now? Andrew, you're writing this, or... Yep.
Can I go grab some sleep?
Yeah, you got 6 minutes. Where are you going?
Cafe or anything?
Ah, yeah, go for good, yeah. No lunch today?
No.
Oh, you better.
I'm visit early.
Oh my goodness, don't kill yourself. Oh. Have you got this? See you in a few minutes.
I'm gonna take a while.
Okay, you'll have to grab